Hi guys, today we are going to be talking about slope and adding a little bit more to our number sense. So before we get into it, let's go ahead, look at this sign that I have right here. So let's just pretend that we're coming back from a camping trip and it says, watch out, steep downhill, or however it's phrased, and you're like, well, how steep is it? And then the sign says, oh, it's 6%. So the question is, what does that mean? Like, we're descending 6%. So if we write 6% as a fraction, 6 out of 100, or 6 parts per 100, the 6% downgrade, what that's saying is pretty much we're descending 6, let's just say 6 feet, 6 feet for every 100 feet of travel. Cool. Now, let's go ahead, come back to the classroom. So again, we are going to be talking about slope, and we are going to denote that with the lowercase m. So you will rarely see me write the word slope. You're just gonna see me write m equals, or slope equals. What's so special about the slope? So the slope tells us how flat or steep a line is. The larger the slope, the steeper the line. The smaller the slope, the flatter the line is. But there are some rules to slope to calculate that steepness. So we are gonna compare the vertical movement to the horizontal movement. So to calculate the steepness of the line, we're gonna compare the ratio of how many steps we move vertically. So whether we go up or down, and then we're gonna compare that to how many steps we move horizontally, or side to side. So again, we gotta go up or down first, and then we gotta go side to side. Why is that the case? Well, that's the only way we're gonna make sure that steep lines have large slopes, and lines that are not so steep have smaller slopes. Okay, so summary: the slope tells us how flat or steep the line is as viewed from left to right. So no one in their right mind is gonna say, oh yeah, I know how to calculate the slope. Oh, I'm gonna take the ratio of how many steps we move up or down and compare that to how many steps we move side to side. In the books, you're just gonna see, oh, slope, ratio of rise to run. So the rise is referred to, the rise refers to how many units we go up or down, and the run, which reminds me of nothing, refers to how many units go side to side. Okay, cool. So let's go ahead, look at the rules of slope. So we already said we have to go up or down and then side to side. But the question is, if I go up, is the rise going to be positive or negative? If I go down, is the rise going to be positive or negative? Same thing for the run. Okay, so rules of slope. So one, you got to go up or down first. Okay, up or down. Okay, up and down, and then side to side. Okay, if you're gonna move up, then your rise is positive, and if you're gonna pull down, then your rise is negative. Now, what about the run, the sideways action? Okay, if you have to pull to the right, then your run is positive, and if you have to pull to the left, then your run is negative. Okay, so that's many words right there. This is a little bit tough for me to digest it without examples. But before we do some examples, you guessed it, more number sense. Let's go ahead, put in some more tricks in our bag, or whatever I'm trying to say, however the saying goes. Okay, so it's always nice if we have a sense of how our graph is supposed to look like before we even lift our pencil. So we're gonna look at the slopes. If the slope is positive, then the graph is expected to point up. Okay, so some of you may be like, well, both of these are pointing up, up here, up here. But when we read a graph, we always read it from left to right, like when we read a sentence, from left to right. So as we go from left to right, if the slope is positive, then the graph is expected to point up. I forgot the arrows. But if your slope is negative, you guessed it, then the graph is expected to point down. Now, what if the slope is 0? So the slope tells me how flat or steep a line is. So if the slope is 0, we're not steep at all. I think I said it wrong. The slope is supposed to tell me how steep a line is. Sorry about that. Let's put that in the bloopers. So the slope is supposed to tell me how steep a line is. The larger the slope, the steeper the line. The smaller the slope, the flatter the line. Now, what if the slope is 0? So then I'm like, oh man, if the slope is 0, How steep is the line? You're not steep at all. Okay, if the slope is 0, then the line is not steep at all. So that means that the line is flat or horizontal. What if the slope is undefined? If the slope is undefined, you really can't see these lines because they blend in with the xy plane. Okay, sorry. I didn't notice that these got cut off. Okay. From the top, okay, if the slope is positive, then the line is expected to pull up. If the slope is negative, then the line is expected to pull down. If the slope is 0, then the line is horizontal, and if the slope is undefined, then the line is vertical. Okay, so with that being said, let's go ahead and knock out our first and only set of exercises to keep this video short. So it says fun problem number 1, draw the graph of a line with given slope that passes through the given point. Fantastic. Okay, so let's break it down. So we are supposed to do the graph of a line. Okay, cool. To do a graph of a line, we need 2 points. But as you notice, none of these problems give us 2 points. They just give us a point, and then they give us a slope. So let's take it from there. So we're supposed to draw the graph of the line that has this slope and passes through this point. The slope is not a point, so I'm not going to start there. So we're going to start at this bad boy. Okay. So we know that 2, -4 is on the line. So let's go ahead graph it. So from the origin, we're going to pull 2 units to the right and then 4 units down. Fantastic. The slope, you can kind of think of directions, directions to get to our next mark. So I know that we have, where do I have space? I don't have space. I'll do it right here. Slope is ratio of rise to run. Okay, we're going to compare how many units we go up or down, and we're going to compare that to how many units we go side to side. So usually I don't like fractions, but when it comes to applying the slope of the line, how I miss them. Okay, so in this case, I want to write the integer 3 as a fraction. So we're going to write it as 3/1. So with that being said, what is my rise? What is my run? So in this case, our rise is 3, so we're going to go up 3. And our run, which is our denominator, is 1. So we're going to go 1 to the right. So from our starting point, not from the origin, from whatever point you graph, you're going to apply these directions. So we have that the slope is 3, which may be written as 3/1. So we're going to go up 3 units and one unit to the right. So we have 1, 2, 3, and 1 unit to the right. We have our 2 points. Let's go ahead, take our straight edge and connect the points. Please use a straight edge for all quizzes and exams. I know you got this, okay? You don't want to get dinged on technical difficulties. So use a straight edge. I say straight edge because it doesn't have to be a ruler. Sometimes I'll get whatever I can find, like an index card or whatever. Use whatever you have, anything that has a straight side. Okay, cool. Now something that I forgot to overlook, again, it's always nice if we have a sense of how our line is supposed to look like before we even lift our finger. In this case, our slope is positive. So we had said earlier that if our slope is positive, then our line is expected to point up. And if our line doesn't point up, then I'm going to start crying. Problem B, okay, let's go ahead and graph this bad boy. So we have that the point is -1, 2, and the slope is -3/4. So again, it's always nice to have a sense of how our answer is supposed to look like. If our slope is negative, I'm like, oh man, is the graph supposed to go up or down? If our slope is negative, then our graph is supposed to go down. So let me just put a little love note to myself. So if my graph is not going down, then I'm going to have a problem. Okay, so let's go ahead, graph the first and only point that we know that's on the line, which is -1, 2. So from the origin, we're going to go 1 unit to the left and then 2 units up. 1 to the left, 2 up. They don't give us a second point, but they give us a slope, so you can kind of think of directions. Okay, so slope, ratio of rise to run. So we have a negative fraction. When it comes to fractions, you can put the negative wherever you like. I don't have space, so I'm going to do this right here. You can put the you can put the negative before the fraction. You can put the negative with the numerator, or you can put the negative with the denominator, which is fine. When we are applying the slope of a line, like directions to get to a second point, we cannot leave the negative in the middle, because then If we leave it in the middle, then we're just saying that both the rise and the run are positive. So pretty much we will be applying a positive slope. So when we apply the slope of the line, you gotta rewrite it. Okay, either put the negative with the numerator or put the negative with the denominator. You won't get a different answer. You would just be highlighting 2 different points. I'm so used to putting the negative with the numerator, so I'm gonna go ahead and do that. In the event that I don't have enough space to follow this game plan, then I'll say, just kidding, I'll put the negative with the bottom. Okay, so slope, ratio of rise to run. Our rise is -3, so we're going to go down 3 units. Our run is +4, so we're going to go 4 units. So remember, when we apply the slope of a line to locate a second point, you apply it from whatever point you have graphed. Some students apply from the origin, but we didn't graph the origin. So please be careful. Okay, so from our mark, slope, ratio of rise to run. So down 3, 4 to the right. So let's do this. Down 3, 1, 2, 3, and then 4 to the right. 1, 2, 3, 4. Cool. Now the question is, what if we had put the negative with the denominator? Would that have made a difference? No, it wouldn't. Okay, -3/4 is the same as -3/4, and that's the same as 3/-4. The worst thing that can happen is, because I have a small graph area, is that we wouldn't have space. But let's do this. So let me just put optional. The reason why I say optional is because you don't have to rewrite the slope more than once, unless like you have a technical difficulty. But when you are asked to graph a line, we just need 2 points. We got 2 points. You can connect them and be on your merry way. I'm just being an overachiever and showing you that what would it look like if we had put the negative in the bottom. So when we write -3/4 in this format, now we're telling the reader that our rise is 3 and our run is -4. I didn't plan this, so let's see if we have space. So with these revised directions, we go up 3 and 4 to the left. So 1, 2, 3. I'm out of space, but I guess we could take it because that's like the edge. So we're gonna go up 3, 1, 2, 3, and then 4 to the right. 1, 2, 3. Oh, this was a terrible example. Okay, I should have planned ahead. Okay, cool. So we have our 2 points. Overachiever, we have our 3rd point. What I wanted to point out is this. When it comes to negative fractions, so this was our starting point. When it comes to negative fractions, I don't want you to worry about, oh man, should I put the negative with the top? Should I put the negative with the bottom? As you can see, it does not matter. Okay, so we have our 2 points. For fake extra credit, we got our 3rd extra point. We connect them, put arrows at both ends, and we're good. All right, for the grand finale, why do we have another positive slope? I don't know, for fake extra credit. Okay, so let's go ahead, graph the only point that we know that's on the line. In this case, it's 3, 4. So we locate from the origin, we go 3 right and then 4 up. Cool. Let's apply these directions. So the slope is positive. So if the slope is positive, then this line is expected to point up. Okay, it kind of looks almost vertical. Okay, so if the slope is positive, then the line is expected to point up. So if it's not, then I'm gonna start crying. So let's do this. So in this case, our rise is positive, so we're gonna go up 5, and our run is also positive, so we're gonna go 3 right. So from our starting point, namely 3, 4, we're gonna go up 5 and then 3 to the right. But as you can see, we don't have enough space to go up 5, okay, much less to go 3 right. So no, this is no good. Okay, because the axis is already labeled, we don't have the liberty to adjust the scale if we wanted to, so we're gonna have to do some detective work. So this is my thought process. It's like, well, if I can't go up 5, then I guess my only option is to go down 5. But check it out. If we're gonna change the directions to the top, then we have to change the directions to the bottom. So original game plan was 5 up. Well, guess what? It's gonna be 5 down. Original game plan 3 right? Well, just kidding. Revised plan 3 left. Okay, so if we go down 5, then we're saying that our rise is -5, and if we go 3 to the left, then we're saying that the run is -3. we are not changing the slope. Okay, -5 over -3 still simplifies to +5/3. But in this case, we had to rewrite it. Okay, just like we rewrote our first slope. You know, the slope was the integer 3. For fake extra credit, we wrote it as a fraction, 3 over 1. Second slope, we rewrote it. Third slope, I wasn't planning on rewriting it, but when you're out of space, you gotta get creative. Okay, so let's do this. So from this revised game plan, when we apply the slope, down 5, 3 left. So hopefully I know how to count. Down 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, and then 3 left. 1, 2, 3. I think I counted correctly, but if not, you can tell me later. Alright, so we have our 2 points. We take our trusty straight edge, ruler, plastic cards work fine. Like if you got like a student ID, cool, that's fine. Alright, so that's it. So that brings us to the end of our fun set of problems. How exciting. Gracias.